All right, so for today, we're going to start with Module 3, which is static map making. And this is part of the Introduction to Map Making in R series, which is a four-part series. So the previous modules were looking at importing, exporting, cropping, projecting, and wrangling spatial data to make it ready for visualization. So now we're ready for the visualization, and we're going to start with static maps, which are just maps that you would normally see in a paper or anything. It doesn't change as you look at it, you can't interact with it. These are your most common types of maps. So first, we need to consider the question, what makes a good map? And if you take in any GIS course, these are typically the things presented. So most maps, they can vary widely in appearance, but good maps are appropriate for publication, have similar themes to one another. They have a title, which gives a description of what the map contains. In publications, this is usually in the figure legend. A legend, which describes what the symbols, so the size, shape, color, etc., represent in the map. A scale, which is a scale bar, describes the actual distance depicted on the map. So, like 1 inch is 100 miles or something like that. The compass or orientation depicts which direction is north. Reticules, which are line and tick marks, indicate longitude and latitude markings. So, anyone can orient themselves based on the universal indicators. The source, who made the map and when, which is usually in the figure legend, or it's the publication authors usually. And then appropriate color schemes. So we talked about this in Fundamentals of Visualization in a different module series, the data wrangling, which was that visualization one. But colors should be logical or cultural, based on cultural or standardized context, like water is blue, hot is red, cold is like blue. Be cognizant of colorblind friendly palettes though, and clashing color combinations, or colors that are just like really harsh to look at, like really bright reds and greens. Just be cognizant of these things and refer to that module if you're of interest for looking at improving your visualizations. So there are many ways to make static maps in R, including using ggplot2, splot, and tmap. I'm only going to focus on tmap because I think it's the most user-friendly one and it's the most intuitive way that's straightforward to adapt a static map into an interactive map also using Leaflet. So the Tmap package, I think is most intuitive because it reads just like any tidyverse language. You add things to the map sequentially, and it's the grammar of graphics. So it's like add a compass, add graticules, add this shape file, do this to the shape file. It reads much better than things like um, other text or basic R plotting, and then it's a little bit more versatile than ggplot or splot. So we're going to read in some of our data we're going to use to create the maps, where today we're going to make a map of Missouri that shows the major cities and all of its streams as an example map, and then add some other things to it. So if you exited out of R before starting this module from the previous ones, we're going to load the packages we need along with the data. So all these packages are for spatial data and for map making. We're going to load the data. This is a stream data set. It is all these streams in the United States. We look at this, we've got things like the name of the stream, a feature, if it's a stream, artificial path, etc. State it's in, whatever region of the United States it is, how many miles it is, and its geometry is a line string. We're gonna filter for Missouri streams only in this. So now that we know how to filter spatial data, we just say filter our stream data set, our state, because that's the name here, state equals Missouri. We're going to read in this states file. Remember how to read in data is read underscore SF, the file path name, and then the name of the shape file. This is outlines of the states. We got region, division, state names, a bunch of other information in here for plotting. The same thing, we're going to filter this for Missouri. Our column is name, all capital here, and they are spelled out. So just put Missouri here for the filter. We can see what that looks like. It's the outline of Missouri. And then we're going to load our exported data we made in the first part of this workshop series, importing and exporting data. This is spatially projected data from the LTRM, or long-term resource monitoring element of the upper Mississippi River, of fish locations that have been sampled, or fish that have been sampled in their locations. This is a raster of Missouri's crops that we had cropped from an entire United States raster. And then these are Missouri cities that we filtered for Missouri and saved as a shapefile. So for Tmap, I think it's a superior mapping package in R because it reads much like ggplot and other tidyverse packages, but it's more powerful and versatile than ggplot2 for map making. You add elements onto the maps using the plus sign, and you can easily add scale bars, legends, compasses, titles, etc. And like ggplot, its code is based on the grammar of graphics, like I mentioned a little bit ago. This type of grammar means there's a separation between the input data and the map aesthetics, and you will specify the data and then add aesthetic elements like borders, colors, shapes onto the map. And you specify the data in this tm underscore shape function, and then you add layers until you reach your final product. So Tmap has numerous arguments that you can add onto this map, including text over polygons, attributes, text size, formats and styles, borders, symbols, everything. You can look at the vignette for this package for a full suite of arguments, and there are many. I'm just going to discuss a couple here to make a decent final product. If you are looking for something more specific, I would look at that vignette or look at online tutorials or anything too. But this is really to give you a foundation of what you can do using Tmap, and then you can build on that foundation yourself. So these are the basic Tmap elements. A few different layer types that we're going to incorporate throughout the module are TM fill, which is shaded areas for polygons. It's going to fill in a polygon. TM border is the border outlines for polygons, so it's just the border. TM polygons is actually both TM fill and borders combined. TM lines is multi-line strings. TM symbols are points. TM raster is for adding a raster. TM text is adding text, like from the attribute tables for your spatial data. So the first thing we need to do is specify our shapefile we're using when we're making a map. We're going to make the map state outline first. And this is a polygon type because we looked at the state outline earlier. So we want to make a map of Missouri. We're going to use TM shape to specify our data first because we always have to use TM shape to specify the data. So we have TM shape, and we had named that outline MO for Missouri. Nothing happens because there's no layer elements. You have to specify your data in TM shape, but there are no elements here, like borders, fill, etc. This is just like ggplot, where you can do ggplot your data, but nothing happens until you add a geometry. It's the same line of thinking for Tmap. So nothing happens with this code because we didn't specify what to do with the data. So let's say we want to fill it in. We're going to do TM shape plus, because we always add the plus sign here. It's just TM underscore fill open parentheses will give us the defaults. The default is this light gray background. and we set it to fill the shape of Missouri. So it did just that. It filled it in with the default light gray. So this was our polygon and is now filled in. Now we have a simple filled in shape of Missouri using the default color. But maybe we don't want to fill in the state. Maybe we just want a border, which is function tm borders with an S there. So just exchange tm fill for tm underscore borders, open parentheses, which will do the same default here. Always specify tm shape in your data up front, plus sign, and then what you want to do. So this is the default for the border is a thin dark gray or black line here. This is the outline of Missouri. We can also add multiple elements like tm fill and tm border. So specify your data set in tm shape, plus sign, tm fill, plus tm borders. There's now an outline and the shape is filled with the default colors. This code is the same exact thing as I had mentioned earlier, tm polygons. So tm fill plus tm borders equals tm polygons. Same exact thing. So now that we have a basic shape or fill, we can add on to this map. So these are two default elements of fill, which is light gray and the border is black. We just had to add the plus in between code lines to add more elements. And that's what we're going to keep doing is just adding more things to this map. So we can add multiple shape files or spatial data frames in the same map. So just have the state outline. What if we wanted to add the streams? We want to add cities. We want to add fish locations. We just keep doing that. So for this example, we're going to add the Missouri outline and the Missouri streams to the same map. Each time you add a new data set, you have to specify that data set within TM shape. And then the code following that TM shape affects that last layer that was identified. So here we have TM shape, Missouri, TM polygons, which is that fill and border, plus a new TM shape. So now we're affecting something else, Missouri stream. We had saved this streams data set that were specifically from Missouri. And we're saying draw lines for it, just the default lines. So what this looks like is the border and fill of Missouri plus all the Missouri streams that are in their line segments. Anything following a new data set will affect the last data set specified. TM lines does not affect TM shape Missouri. It only affects Missouri stream. That's important to know. Okay. So both of the above data sets are lines or polygons. What if we want to add a raster to the map or points? If you watch the other two modules, you'll know that rasters are a pain to work with. So I'm only going to show it as an example here. We're adding the crop raster to this map, but I'm not going to show more information than that. If you are interested in rasters, you can look elsewhere and hope that you have a faster computer than the one I do. So we're going to add our crop raster. And if we remember from the first section of this workshop series, that this raster crop had a different coordinate reference system, or CRS, than our state data. And this coordinate reference system is important because they need to do any spatial analysis, you have to be in the same coordinate reference system / projection. However, with Tmap, you don't need to reproject to the same coordinate reference system because the package will do it automatically. And as a note, we're not going to use the raster for Tmap again, but this is just to show you how to add the raster. So we have TM shape plus fill and borders, and that's Missouri only. And then we have TM shape specified again, and we're doing the crop crop shape. We're doing that Missouri crop. And then we say, because it's a raster, TM underscore raster. And we're saying legend.show equals false because it would make this massive legend because of all the different crop types. So we're just going to say, do not show the legend for now for our purposes of just showing what this looks like. And it might take a moment to run here, hopefully. Okay, so I left this to run for a bit and it ended up crashing my R session. So we're not going to run the raster again. But if you have a raster, this is how you would add it. It's just they're so large and sometimes computers can't handle that. So I would work on a better computer than like the kind of crappy laptop I have, unfortunately. Okay, so I'm going to dismiss the rasters for now. So instead of a raster, let's add points to the map. So we're going to add the Missouri city data we cropped at the beginning of this module in the first section of it. So these were Missouri cities like larger than 200,000 people or something like that. So we have our shape of Missouri, we have our fill and border, or this could be polygons. We're specifying our next shape as the Missouri cities 2 data. And we want them to be just like regular symbols. We want them to be points, essentially, for these cities. So that's TM underscore symbols default, and that default is a slightly less light gray than the background default. So these are all these cities that are larger in Missouri. Okay, this is actually along a highway for all these cities up here, same with the ones in southern Missouri. So that's how you would add the defaults to these different maps. And then finally for this, we're going to add the city names as text so we know what cities we're looking at. So we look at the Missouri Cities 2 data. Name is our city's text. Blue Springs, Chesterfield, Columbia, etc. So all of this is copied and pasted from before. The outline, or the Missouri state outline filled and bordered, and then our Missouri cities 2 with our points as the TM symbols. And now we just say plus TM text of the column we want. So that would be name because that contains the names of the cities. And that must be in quotation marks. So now we have all of the cities named on here. Yes, they are overlapping. Yes, we can change that. We will work on this, but that is how you add several elements to the same map. And you can keep adding like 50 different elements if you wanted, 50 different data sets. Whatever you wanted to do, you can keep adding it in through the TM shape specification of the data. So this isn't great for a map because things are overlapping. It's all grayscale, but we're going to edit things on here as we learn how to do some more of that. So now we've put 2 different data sets to the same figure using the TM shape function to specify our data each time. We have a polygon on here, we have points, we also have the polygon and lines for the streams. And we've used the subsequent TM underscore X, where X is text, symbols, etc., functions to manipulate the previous TM shape data. So again, we could keep doing this until we run out of data sets, but we also want to make a functional map. So we're keeping it simple right now, just the 2 different data sets. And we're going to talk about the elements of the map now. So one thing that's really important is this layer order. So we're going to talk about mapping order. Each new TM shape specification of your shapefile or whatever spatial data you have is a new layer to the map. And when you add layers in subsequent order, the information can be covered by the new layers. So basically, you're starting with the outline, and on top of that outline, we add the streams, or we add the cities. So the layer order does matter, and we're going to see what this means here. So let's say we want to make a map that has the border of Missouri, the streams, and its crop cover. We're going to not do the crop cover because that raster didn't work. We're going to do the streams and its cities here. So we'll need to pay attention to the layer order to make this map well. That's actually something more visible. So this first example layers the Missouri outline. We got our TM, Missouri is our shape, fill, and borders. And that's just our Missouri outline polygon there. Then we have the Missouri stream specified in this TM shape, and we're making that lines. So this is what we made earlier, all of the streams here. And then we're going to add another data set, the cities with symbols. So we're just adding a third data set here. So those symbols, they are default gray, so it's a little bit harder to see, but they are on top of those streams, on top of them. If this was still the raster, I'd change this mid-workshop because the raster wasn't working, unfortunately. But if there was a raster laid on here, you wouldn't be able to see the streams at all instead of the cities. So we can still see the streams, we can still see the cities. But what is this going to look like if we switch the order? Let's say we put the cities first. So what this looks like is it doesn't really have any spatial extent for us visually. There's no border, there's nothing, it's just the cities plotted. Then we put the shape on there with just the border. Okay, it's zoomed in on those cities still, rather than the whole outline of Missouri. And let's say we put the streams on here next with TM lines. It's really, those lines are overgoing those points because we added them last. So all those points have lines going through them of those streams because we added the streams last. And this map is zoomed in on the bounding box of our Missouri city points because we specified that as the first layer. Here we have the map, the whole outline of Missouri because we specified the polygon as our first layer. So what Tmap does is it not only it layers things in the order you put them. So here was Missouri cities, then the shape of Missouri, and then the streams. So the streams are overlaying those cities on here. But it also zooms to the bounding box extent of the first layer specified. So the Missouri cities and all the other data is added on from there. And that's why it's more zoomed in than the other one where the polygon was specified first. So we see the entire, all of Missouri for this one. So this is really important for layer ordering. Things add on top of one another, and the way it's zoomed in or that bounding box is going to matter based on your bounding box of your data you want, or that data you specified first. So the mapping aesthetics here. Aesthetics regard how the map appears, including things like color, sizes of objects within the map, whether we have a compass and things like that. We can alter every aspect of the map in each layer using different arguments with tm_x functions. So again, we're going to start with our basic map of Missouri and its cities and build up from here with aesthetic features. So just the basic map, the cities plotted on here. We can change aesthetics globally, all elements affected the same, or by a factor or variable in our data, just like we can in ggplot using the AES for aesthetics function. If you're familiar with the global versus aesthetic parameters for ggplot, it's very similar for Tmap. So first, we're going to talk about color. Consider the principles of color selection and how to select colorblind friendly palettes for maps. Like, do not use red and green in the same map. This information is here for your later perusal for selecting color schemes, and I will not be going over it today. It's about fundamentals of color choice. It is also talked about in the Color R Brewer module for the visualization and data manipulation workshop series, as well as the fundamentals of data visualization. If you are interested in this, look further at the R Markdown document or the HTML file. But we're going to jump right into color. So here we're going to manipulate color both globally for a layer or aesthetically, which is by a variable. To do it globally, say we've got our TM shape here, TM fill, we're going to say col for color, COL equals blue, the name of the color in quotation marks. What's nice about RStudio is that it shows you the color now when you have a real color that it knows the name of. So we can change this to like black. It shows black, whatever we want there. And we're going to add a TM border, col equals red. It's going to be a very ugly figure. It's fine. So if we just look at that, TM shape, red border, blue fill. All right, now we're going to add the Missouri cities. We're going to say for this data set, col equals pop. What does that mean? Whoops. If we look at our Missouri cities data, we have this pop metric, which is population. So we want to color the points by population so we can get an idea of like population size. So this is an aesthetic color scheme because it's not an actual color, it's a variable in our data set. And we're going to set the palette or colors to be set1. It's a set palette within R. So what this looks like now is it automatically creates a legend, which is kind of difficult to see with the clashing colors and the overlap here. But all of the points are different colors based on their population size. And what Tmap does is also set specific cutoffs. So this is like 1 to 1,000, 100,000, 100,001 to 200,000, etc. And it's coloring that way. So this is a pretty horrendous figure with the colors. It's not pleasing to look at, but you understand the idea of changing things globally. So the blue and the red, blue fill, red outline, and aesthetically. So the elements based on a variable, which here is population size. Next, we're going to look at size and shape. So we can alter how our elements look via shape, size, transparency, which is alpha. And we use these things to highlight different aspects of our map or draw attention to specific data. So first, we're going to alter some of these elements globally so it affects all borders and symbols equally. Here, TM shape Missouri, we're building on the same figure. We don't have any color in here, we're just looking at size and shape right now. TM fill, we're leaving as the default gray. TM border, so the outline, we're going to say line width equals 3. That's going to be the thickness of the outline. And this is line type LTY. We're going to make it dotted. So we got our border. We changed this to be a thicker border than what we have been having. And it's now dotted rather than solid. The default is solid, but you can change it to dotted or whatever other arguments there are for that. Again, we're adding our Missouri cities. In TM symbols, we're making them size equals 1 and shape equals 13. There, I think, are 26 different shapes in R for symbols. And you can play around with whatever shape you want to use for this. If we do this, it's a faint circle with an X going through it. We can change it to like 18 or something like that. It's now filled in diamonds. So whatever shape you are interested in, you can change that here using just shape equals the number. And size is the size of the point, so we could change this to 3. and they're much larger diamonds. Okay, we can also alter size and shape based on a variable in our data, which is aesthetically. So here we're going to alter shape by population, just like we did with color. This first part is the same, except we now have alpha equals 0.5. So this is transparency, and 0.5 means 50% transparency. We don't see it very well here, but it is more transparent outline from this map, which looks darker, to this map, which is much fainter. That's what alpha does, is just alter transparency of that. So now we add our Missouri cities. We say TM symbols. We still have the size equals 1, so that's going to be a global size change. But our shape equals pop, that population variable that's within that data set. So what this is going to do is it's going to change the shape of those symbols. So now we have circles, triangles, and squares. We have upside down triangles and diamonds as well in here, at least in the legend. And it gives us the legend as pop, and it gives us those cutoffs of what those shapes mean. So that's how to change it aesthetically or by a variable. We're going to get into some altering map layout options. So there are many elements we may want to add or alter to the map, such as titles, legends, text size, etc. We can alter all of these things with tm_layout. It's basically the themes function in ggplot, if you're familiar with that. So first, this is the same thing that we just made. It's copy and pasted. Whoops. If it would run. I don't know why that's not running, but interesting. I think there's something going on. Okay. Oh, it should run. It's like missing a parenthesis. Okay. So same thing we just made right here. We got our population legend, we have the default gray colors, everything like that. Same exact thing. Now we're going to use this tm_layout and say our title equals cities in Missouri. We want a title for our figure. We want to alter our title size, so title.size equals 2. And title.position, we want it to be the center in the top. So we can say concatenate this, center, top. Cities in Missouri, it does overlap with the border and fill. But now we have a title, size 2. We could make this size 1 if we wanted, so it's much smaller. So size 2 is more appropriate. Title position, we could also change this to like left top. If you do capital left versus underscore left, or not underscore, lowercase left, it just changes like whether it's snapped to the left or if it's at the left, basically. It's some nuances with their information on here. But we can alter this whatever way we want. Top, middle, I think it might be center actually. Yeah, center. So left and center now. It's always left, center, right, or so it's like horizontal this one, and then vertical this one, so top, center, or bottom. So you can play around with the position of titles. Usually it's center and top. So that's what makes the most logical sense to our brains usually. We can change the legend position as well. So let's make it left and bottom, for example, where there's more white space so it's not overlapping and hard to read. All right, same exact code from before. Now we're just adding a comma and then legend.position equals left, bottom, bottom is capital here. And that's going to put that legend the left and bottom. If we make that lowercase, let's see if that it just moves it up a little bit. It doesn't snap it to the bottom. It leaves like a hanging blank space there. So if you want it snapped to the bottom, it's uppercase. That's the same with left, center, top, everything. So it just moves it down a little bit, snaps it closer. All right, so we move that legend. It's more readable now. What about altering the margins so the legend and title aren't covering the map? We would like them in white space so it doesn't cover what we have. All right, same exact code. Altering a legend or altering a title here, altering our legend. Now we're changing the margins of the map. So we're saying inner dot margins for this one. And we do concatenate here and we just put in our margins. So these are 4 values between 0 and 1. And this is to make the elements of the map fit better. So it goes bottom, left, top, right. These are between 0 and 1 for each one. I played around with this before recording to know which ones to put in there, so you can alter them however you would like. But this just alters those margins, and so now, because the plot text or the plot title is snapped to the top, it goes with the top. And same with the legend, it goes with the bottom because it's snapped to the left and the bottom there. So if we expand those out, we get a better view of those data, and it's not covering the map. We can keep going on with altering aspects of this map using the TM layout function. So many things. You can do text, colors, more elements of this, whatever you want to do. We can search that TM layout to see how many arguments you can include in this function. We're going to do that just as an example's sake. All right, layout of cartographic maps. TM layout. We have title, scale, title dot size, background color, sepia intensity. There are legends, titles, panels, main text. There are so many different things you could add into this to customize your map any way you want it. So look at that more if you want to customize in different ways. So we're going to move away from that layout because you can play around that yourself to see what you want to change. But now we're going to add legends. So when you vary something aesthetically, so like by a variable, it'll automatically create a legend. But sometimes they're not the most intuitive legends. You want to alter the cutoffs in it. You want to add your own legends. Like when we add the stream data, it doesn't say what those lines are in a legend, but maybe we want to add that in there. Because most maps have a legend that aren't just including the aesthetically altered, so that by a variable like population in this map, values for shapes, and whatever. We often have lines for streams, bridges, land features, etc. in a legend. So you can manually add a legend to a map using tm add legend. This function allows you to add as many map elements as you want in whatever order you want. So it really allows you to make your custom map. So we're going to add the Missouri State outline with the streams as blue lines. So this is pretty much what we've done so far, but now we're adding specific colors, changing line width. So we're adding the border from the Missouri outline. The border will be black and the line width will be 3. We're filling it in with a light gray. And we're adding the Missouri streams data and making the lines blue. So what this looks like is we have a thicker black border, we've got a darker gray background, and those Missouri stream lines are blue. Cool. That's what we specified. But usually on a map, you want to say what those blue lines actually mean, what the black line border means. So what we can do is say tm add legend. The type here is line, in quotation marks because these are both lines. So the black border is a line, the blue is a line. Because we're adding both of these to the legend, we can say call for colors and then concatenate them together. Blue and black, because that's the same colors we have here is blue, black. Line width, whatever line width we want in this legend to match what's in the map. So we're saying 2 and 3 here. Our labels for our legend. This is what's going to show up in the text for the legend. So we want to say blue corresponds to stream. It's always this first one, blue, line width 2, name of stream are going to group together. And then the second one, black, 3, because line width was 3 for the border here. That's the state border in quotation marks. And then you can give your legend a title as well, and we're saying title is key for this. So we add this together, and we've got it overlapping the map because the default is to put it in the bottom right, which does not work well for our map. So then we're going to say TM layout, which we just learned how to change legend position. Legend.position equals left and bottom. Snap it to the left, snap it to the bottom with those capital letters. So now we have a legend that is called key, we have stream border, and we have state border. So that is an easy way to add things. If you had multiple types, like line and symbol, you could say C, line, symbol, and go from there. And this would be blue, black, 2, 3 labels, argument type. You might have to add this in a different type then. But I would play around with that if you had multiple types there to see what you have to do for that. But because they're both lines, you just say type equals line. But you can keep adding multiple elements to that same legend. So you could add the city points to that. You could add other shapes, more lines, different colors, etc. Okay, this is going to alter our legends that are automatically created using the aesthetic features. So again, R automatically creates a legend for your map if you're varying something aesthetically, so like by a variable like population size. So, but you can still alter every aspect of that legend it automatically creates. And the basic format for altering a legend is to specify the aesthetics you altered within the legend arguments. So this is an example here. So we have TM shape Missouri, TM fill, TM borders. We're going back to our line with a 3, our dotted, and our alpha. And then we're adding Missouri cities, which we have been doing. But now we're changing not just the size and shape. So the size is going to be 1, the shape is going to vary by population. But we're going to add some other things to this. And again, as a reminder, it creates the default legend for this of pop, because that's what the variable is called in the data set. Automatically changes what those shapes are and those cutoffs. But we want to alter this a bit. So we want our title.shape, our title of our legend, and it's title.shape because we're changing shape by the variable. So this has to be whatever this is. So if we had color here, this would have to be title.col. But because we're altering by shape, we say title.shape. And then we're naming it population. So it's going to go from pop to population. And then shapes.labels. And we say concatenate because we're going to put them all together. Instead of 0 to 100,000, we're just going to put 0 to 100K. 100 to 200K, 200 to 300K, so forth. Just make this a bit shorter to read for us. So now we have population as our legend title, and we have it to be 0 to 100K, 100 to 200K, 200 to 300K, etc. Okay, here's another example of altering the legend if we had altered point color instead. So here we have color population. Everything else is the same. Copy and paste it. Just change this to col pop. Palette is dark 2 for this. So what that looks like here initially is we've got that legend varying by color. And this is our dark 2 palette, which is inherent in R as a palette. Okay, but we're going to keep going. We're changing that title.col. So you remember, not title.shape, title.col, because we changed color by that variable aesthetically. We're naming it population, comma, labels. So this was shapes.labels. The default for labels is to change color. So it doesn't have colors.labels, doesn't have col.labels, it's just labels. But you can't just use labels for shape or size. You must use shapes.labels equals for shape. And then this is the same cutoffs we had made in the previous one. It's just different nuances between color, shape, size, etc. So this is something to think about. But that makes a more custom legend. You can also alter what colors they are, what shapes they are, things like that as well. Other map aesthetics. So we can add latitude and longitude tick marks. And it's a great way to orient a viewer to a map and make sure it's consistent with the other maps. What you do is just use TM graticules function to add the lat and long lines, tick marks, labels, etc. So this is our same map or a map we've been making. We changed the palette to be the default. So we didn't specify a palette here. It's just col equals pop with no palette specified. This is the default. They're like yellows to browns. And we're going to add this TM graticules. So it's the same map we've pretty much been creating. It's just a different color scheme than this last one. Otherwise, it's the same. So it's just plus TM graticules. And it automatically adds latitude and longitude lines here. It also adds this nasty grid. And it's annoying. I don't know why that's the default is to add this grid. But you can change that using lines equals false to remove the grid. So then it just gives you the lat and long on the side, which is much nicer. It's cleaner to look at then. So that's just lines equals false. We can add a compass to orient our viewers to the cardinal directions. So everything here is the same, copied and pasted from above. We're just adding plus TM compass. Now we've got a little compass in the bottom. Everything here is copied and pasted from above. We're now just adding a scale bar. We did not add the lines equals false here. Just add that, but it's plus TM scale bar. Very simple. Now we have a scale bar next to the compass, next to the legend. So we've added three things: the graticules, the compass, the scale bar, and it's just adding them in a logical way here by just naming them. These are the default graticules, compass, and scale bar aesthetics and position. You can change the position, style, etc. of each of these elements to make them more aesthetically pleasing and to not hide the rest of the map or to not cover things. So what we can do for the graticules, say lines equals false. We don't want those nasty grid lines. We want the labels, colors to be black rather than the default gray. So what this looks like, now those labels are darker. They're black Here, it's a little hard to tell on the computer, especially, but they're gray. The black just helps them stand out a little bit better. But you can change them to whatever color you want. I wouldn't recommend doing other things, but here's blue, for example. Change it back to black. All right, for TM Compass, you can say type, and you can change the type to whatever you want. Here we're going to put a rose instead of the default. There's a number of types you can do. We just look up TM Compass. Type. We have arrow, 4-star, 8-star, radar, or rose. The default is arrow. But you can add any of these other ones. They just have to be in quotation marks here. So we're doing a rose, and we're going to say position equals right top. We want that to be out of the way. It is the right top there. So now we have the black graticules, and then we have the compass rose here. We can alter other things like text size of it, labels, which directions are used, the text color, etc. So you could add a lot of different things to your compass rose and to any of these elements. And then finally, we'll alter our scale bar. We want it to be size equals 3, so we're going to make it bigger. And we're going to say move it away from the default of the right bottom. We're going to make it left bottom for this. So now those aspects are out here. The scale bar is much larger. It's in the left bottom. The compass rose is at the top right. Our population legend still overlaps with the data, but we've known how to change that already. So now we're going to combine a plot. So combining all of the elements we've talked about to create a nicer looking map that includes streams and major population centers in Missouri. So we're going to combine everything. All right, we're going to start with the border of Missouri. TM shape Missouri. We're filling it by the default gray. Our borders are going to be larger, line width of 3. Line type is solid, not dotted, and our color is black. So we got a Missouri outline here. Default gray background, thick black border. All right, next we're going to add our streams. Missouri streams next. TM lines. And we want the color to be cornflower blue. It's less harsh than the regular blue. So now we have a nice light, less harsh blue as our Missouri streams lines here. We're going to add Missouri cities. We want the size to be 1. We want the color to vary by population. And our palette is going to be yellow, orange, red, another default palette in R. We're changing the title of that legend to be population, and we've changed the labels the same way we did earlier. So, all right, it creates that default legend, which is covering part of the map, so it's not really readable. But the points really stand out in these colors for this color scheme, the yellow, orange, red one. All right, we're going to add our graticules. We're going to remove those nasty grid lines, and we're going to make sure that the labels around are black in color. All right, we got our graticules on here now. I'm going to add our compass. It's going to be a rose. For position, you don't just have to put like top left or left top or whatever, center and stuff like that. You can name or you can put the numbers in here, which I believe are like between 0 and 1 or -1 and 1. So you can put numbers in here too. I did this before to figure out which numbers would work well. So this is another way you can alter specifically where things go. We do this, and it makes a compass rose. And if we alter these numbers, we can put it somewhere else. So now it's up a little bit higher. That's another way to do that rather than like center bottom kind of stuff. All right, so we have a compass rose on here. We've got our graticules, we've got our points, our lines, and our multi-polygon, and our legend. We're going to add our scale bar. Our size is 3, and we want this to be in the center bottom where there is space available. All right, center bottom. Here we go with the scale. Perfect, scale bar in the center bottom. Okay. Now we can alter the rest of the layout. We want to add a title. We're going to say Missouri Rivers and Population Centers. So that's what we have. We're going to say title size is 2, title position is center and top. Our legend position, we're finally going to remove this and put it in the left bottom. And then we're going to alter our inner margins like we did earlier so the title and that legend aren't overlapping the rest of the plot. All right, now we have the compass moved up there, which is probably why it was a different place earlier. So we're going to move that back down. Yeah, so now we can see the whole compass. We have our title, we have our legend moved, we have our scale bar, and we have the graticules and all the other information. One thing you'll notice, if you look really closely, the Missouri streams are on top of the border. So there's a little bit of blue bleeding into the black border of Missouri. And that's because we have a thicker line width for those borders, and we put these streams as the second map element on top of the borders. What you could do, if you want that removed, is you could put the shape Missouri streams first. See? It doesn't do anything because this is why layer order is important. We have the default fill here. We wouldn't want a fill then if we had that first. So we just would want the borders. But then it's white background there. So this is something to keep in mind that if you put stuff, when you're layering stuff or changing thickness of lines, is that if you have the thicker border and put the lines for the streams on top, those lines are going to go into that border because it's thicker, because it's moving into where those lines are. And if you put the streams on the bottom or the top, the firstmost layer, and you have a fill, it's going to cover the streams. So if you don't have a fill, you won't have any dark background, which may be fine. It also might make this blend more into the background of the whole map in general. It's whatever you feel most comfortable with. Here we don't really need the gray background. This would be fine. We don't have lines running into the border because they're the blue lines are the first thing mapped. And we don't have them zoomed into the like cities in that weird bounding box like we had earlier with the map order, because the lines are for this whole outline of Missouri. So our bounding box is the same as our Missouri outline for this. Just something to keep in mind for aesthetics with this stuff when you create a whole map here. All right, we don't have the black border and the blue lines in a legend here, but those could be added like we showed, or I showed for adding your own legend like we did earlier. All right, we're going to do one more example where we use the fish collection sites from the LTRM data that we had made spatial in the first part of this workshop. For this one, we're going to use dplyr on the spatial data to wrangle it first into fewer data points that fit within the bounds of this map. Then we're going to map it. So this spatial data is called fish locations. And within here, we're looking at pools. Pools OR, which is Open River, and Pool 26. Those are the only pools that are along Missouri. I know that because I know these data. You might know that if you work with these data or looked at them further or tried to map them. So we're just going to filter these two pools that actually go into our map. And we're going to mutate species as a factor so we can color things by it. We're going to save that as fish OR26. All right, most of this is the same. All of this is the same. And we put our streams first, our border second. So this is the same. Streams, border. Rather than the city points, we're putting TM-shaped fish OR26, the one we had just done for our fish that were collected in the open river and pool 26, which are pools along Missouri's border within the Mississippi River. Our symbols are going to be half a point in size. The color is going to vary by species, and our palette is set one of the inherent palettes in R. Everything else, graticules, compass, scale bar, all the same. Our layout, our title is now Missouri Rivers and Fish Collection Sites rather than cities. Pretty much everything the same. We're just making it a different data set. So now we have, instead of the Missouri city points, we have these fish collection points, and we have the colors of the fish. Color varies by the species here. So we can see that along here that these are where the two pools are. Pool 26 is the northern one, Open River is the bottom. So this is just an example using a different data set and how you could use that same basic background and same like foundation of the Missouri map and its streams to map other data on there and show a completely different map. So I would recommend always when you find a base map that you like or you're going to be working with a lot, just copy and paste your code from map to map and then change the things you need. Like this one, we literally just changed which data set it was and any information on those symbols. So like the color, what variable they changed by, and the size of those symbols. And then the title. Everything else pretty much stayed the same. So faceting maps. You can also do facet maps by a variable, which is making separate mini maps for a variable of interest, like fish species, state, continent, etc. Okay, so all of this is pretty much the same that we just did. We just made this map. It is the same, except the shape, Missouri shape is first rather than Missouri streams. That's the only difference here. Otherwise, it's the same. If you're familiar with facet wrapper, facet grid, and ggplot, facet by some sort of variable, so it's the same thing, except it's just tm underscore facets. And you're saying facet by, here we're going to facet by species. That's the variable in the fish data set. This tm facet corresponds to tm shape fish OR26. We're going to facet by species as that variable. And we're going to say the free coordinates equals false. It defaults to true, which says that each map should have its own coordinates, which will be zoomed in on the points only and not show the whole map. So we're going to see what that looks like. Here it's going to zoom into the bounding box of all the points in fish OR26. So what this does, it gives us a map and it facets for every single one of our species. It does alter where the title goes and stuff and everything, the legend and whatnot, but it gives us a whole map of what we had just created, the whole outline of Missouri, and shows the points, which for this is not very helpful. These are very small maps and the points are all really tightly clustered, but you get the point that it's going to make mini maps of every single one. This is with free coordinates equals false. If we put this true, it's going to zoom in on each species. This is a moment to run. All right, it zooms in on where all of those species were collected, which this largemouth bass is, I think, just an extraneous data point in here, but all the other ones, it pretty much zooms in to the bounding box of where those fish were collected. If you had fish all across the state rather than just these two pools, it would zoom into the specific locations where that species was collected. That's the difference between free.coordinates equals true and false. We can't tell a lot with these maps because they're small, but we can make them bigger when we save a map. Okay, so we're going to save a map, and we can quickly save the map we created as long as you save that map as an object. So far, we have not been saving them as objects, we've just been running them to look at them. So we're going to save our last map as an object called Missouri map. We're going to look at the Missouri map here. Perfect. That's what we had wanted. It's back to the Missouri rivers and population centers. This is what we're going to save now. So we've saved it as an object called Missouri map. And so now that we've saved that, we can use tmap save to save our map. This is just like GG save or anything else to save a plot. It's tmap save Missouri map, the pathway of your file that you want to save into. This is just going to save it into the same file this R Markdown document is saved in. And we're saying map of Missouri rivers and large cities. That's what we're going to name it with the extension .tiff for TIFF. So this is going to make a TIFF file, which is a high resolution image. You can also save as other extensions like this one, a same exact code except it's .svg. It's a vector graphic that you can alter in programs like Inkscape or anything like that. Just depends on what you need to save it as, or if you're altering it further in a different program, what you're going to save that extension as. Could be .png, .jpeg, whatever you are interested in. I recommend TIFF or SVG because they're vector based rather than pixel based. Okay, and finally, we're getting close to the end here. It's been a long workshop for this one. The map insets. So a lot of times in publications, you will need a map inset to highlight where in the world your study is taking place. I saved the map inset for last because we need to know how to save a map first for it to save the map inset on another map. The insets are basically just small maps that orient the audience to the broader geographic range of your system. So for the Missouri map, we might want to add a small map of the United States with Missouri shaded to be like, this is where the study takes place. So what we're going to do to make that USA map with Missouri shaded is say, okay, we're going to make states filter, states. We're going to filter for region 9, which basically is just the states of the United States and not its territories, because this state's shape file contains the territories. And then we're going to remove Hawaii and Alaska. And if you don't know how to filter, look at the module for filtering or wrangling spatial data. So this is just going to create the lower 48 states. Our Missouri map here is what we've just made pretty much. But we're doing the fish ones instead. And things are kind of in different places. We've altered what legend it is or what compass it is. We've altered the legend and it's overlapping here, but when we save it as the object, it won't be overlapping. One thing to keep in mind is that when you save something with specific specifications, whether it's a ggplot, whether it's a map, as a TIFF or SVG or anything, the dimensions might change based on what you specify when you save the map. So what it looks like in the preview in R may not be necessarily what it looks like when you save the file on your computer, and you may want to alter legend sizes, text, positions, and whatnot based on how it's actually saved in your computer. So right now it looks kind of awful. When it saves, I promise it'll look not like this. All right, so that's our map we're saving, but we want an inset of it as well. So we're saying take our filtered data set of the lower 48. Our borders are going to be black for the states. We want to do TM shape Missouri as well, and we want to fill that in with black. We want it to be shaded. So if we run this and look at our inset map, it's the lower 48 states, the United States. All the borders are black around the states, and Missouri is shaded with black. So this was going to be our inset to show this is where Missouri is. That's where our study is. So Tmap save, you can have a lot of different arguments in Tmap save. Our big map is Missouri map. It's the fish collection sites there. That equals Missouri map. Our insets TM is our inset we just saved. We named that inset. This is inset viewport. Where on your map your inset will be placed and how big it is. We're putting it in the X and Y coordinates here, and I had selected them based on playing around with exporting this file and seeing where that inset is located and then altering based on that. Our width is 2 inches. We say unit, we're saying it's 2 inches. You can put centimeters or whatever here. Our height equals unit 2 inches. So we're making a square inset map. Close out that viewport. That's how you edit the aesthetics or the size and placement of your inset. And then file name is just, it's the path as well as the name of what we're saving this as, which is map of Missouri with inset.tiff. So I ran this earlier and saved it. I'll pull this up. This is what it looks like. See that the legend is not covering the map anymore. When we saved it, it was saved in a way that makes a lot more sense and actually looks nice in the final product, even though it might have looked not great in the preview. And then our inset here is in the top right, where we have the lower 48 states, borders, and Missouri shaded. You can remove this border around the inset if you would like with some other arguments, but this is just to show that there is an inset there, and that is how you would add it in. You can alter where the inset is locationally, as well as the size of it. All right, so that is the last part of the static map making in R part of this workshop series. If you want to test your knowledge, I recommend doing the exercise 3 static maps that will use other data sets and ask you to make static maps with those data sets using the principles of elements, adding different map aesthetics, adding different data together, layer order, and whatnot. So the final module will be interactive maps after this. But you should be able to use the static map making module as a foundation to make customizable static maps in R using the Tmap package.